Okay, well this is going to be interesting. This is the first time I've attempted at making a video using my smartboard. We're going to see, basically I have one shot to get all the way through this without making any mistakes. And that's not very likely, so we'll see how this goes though. This lesson or video is going to be on negative exponents and how they're related to multiplicative inverses. Okay, so we're going to start off with a fairly easy example, 3 squared. And we've talked about this before in class. You've learned about it in other classes. What does 3 squared mean? Well, it means 3 times itself twice, or in other words, 9. Okay. Now we could extend this to 3 cubed, and if you didn't know, you could probably figure out that 3 cubed means 3 times 3. That's a 3 there, times 3. Got some lag in my video apparently. And so that equals 27. Okay, and you could keep going up. 3 to the 4th would be 3 times 3 times 3 times 3. And that would be 81. Okay, so we go the other way. 3 to the 1st. Well, that's just 3 times itself once, which equals just 3. Now you maybe think that it's kind of redundant to put the 3 equals 3, but there's a reason you'll see here in a little bit. So we notice this pattern that as we go up this list here, we're timesing by 3. Okay, each time we multiply by an extra power of 3, we're adding an extra 3 here, well, timesing an extra 3 here, which means that this answer here will be 3 times greater than the answer below it. Okay, so what does this have to do with negative exponents? Well, we can go down this way by basically undoing this multiplication by 3. So if we divide by 3, we can figure out that 3 to the 0 power must be, well, following this pattern that we have here, should be 1, because 3 divided by 3 is 1. And then 3 to the negative 1 should then be 1 divided by 3, or 1/3. Okay. Now 3 to the negative 2 would then be 1 over 3 times 3, which equals 1 over 9. And you could keep going. 3 to the negative 3 must be 1 over 3 times 3 times 3, which equals 1 over 27. Sorry, my 3's aren't really working out very good today. Yeah, that's no better. But hopefully you get this idea. So these negative exponents down here are basically the same thing we have up here, just flipped onto the denominator in the fraction. Okay, so we could actually do this with any number. It doesn't have to be a 3. It could be an x. And we could go through and we could make this exact same list, and it's going to look very similar. X to the 1 is just going to be x. X squared is going to be x times x. X cubed will be x times x times x, and so on. Okay, and on the way down, x to the 0 will be 1. X to the negative 1 will equal 1 over whatever x to the 1 equals. And then x to the negative 2 will equal 1 over x squared, or, whoops, or we could write it 1 over x times x. Okay, x to the negative 3 would be 1 over x cubed, or if you wanted to, you could write it 1 over x times x times x. Okay, and so on. We could make that list go on forever in that direction. Okay, so this is the idea that, excuse me, that negative exponents are basically, these guys right here are just these guys flipped, okay, with the fraction where the numerators now become the denominator. The denominator, which up here, you know, we could have written it as a 1, has now moved to be the numerator. Okay, well, if you recall back in, I don't know, the very first couple days we did stuff in this class, we talked about multiplicative inverses. Okay, well, a multiplicative inverse, let's let my pen write it down. Yeah, it's losing it. Inverse. Alright, maybe I won't try and write words anymore. Multiplicative inverse, if you remember, is the number we times by another number to make it equal 1, which is the multiplicative identity. Now, that's not too important for you to remember for this particular video. But what we're saying here, say I have 1/2. What would I times 1/2 by to make it equal out to 1? Well, I would times it by 2, which we could write just 2, but I might as well write 2 over 1 because we're kind of talking about fractions here. And notice that these two are just reciprocals of each other. We've just taken the fraction and flipped it. Okay, that is what a multiplicative inverse is. Essentially, it is just the flipped fraction or the reciprocal of the fraction. So going back to these guys, you can see that the multiplicative inverses of the guys up here are these guys down here. Okay, and even more specifically, the multiplicative inverse of, say, x squared, which equals x times x over 1, if we wanted to write it down like that, its multiplicative inverse is x to the negative 2, which would then be 1 over x times x. Okay, now the great thing about this is why we teach it to you in this class, is that this not only holds for multiplication of monomials, which are these guys, so it also holds for addition of their exponents. Okay, so here's an example of what I need. So let's use that x squared example. So x squared times x to the negative 2. Okay, well, x squared is x times x over 1. X to the negative 2 is 1 over x times x. If I multiply those two things together, since they're multiplicative inverses, I will get 1. Okay, now you could actually go through and multiply these two fractions out and get x times x over x times x, and then cancel out the common factors, and we end up with 1. But we don't have to do that. We can use our shortcut, which is add the exponents. So right here, x squared times x to the negative 2 is going to be x squared, well, I should say x to the 2 minus 2. Well, 2 minus 2 is 0, and as we saw earlier in this video, x to the 0 is 1. Okay, so it works out. This result here gives me the same result doing it the common sense way. Okay, so what's neat about this is the rule holds. The rule for multiplying powers, where it says if I have, sorry, that didn't work out very good. If you have two things with the same base and you times them together, you can just add their exponents and it'll give you the answer. Okay, so going back to this idea of multiplicative inverses, okay, these two are multiplicative inverses of each other. And hopefully you realize that these two, the 2 and the negative 2, are additive inverses of each other. And if you don't remember what an additive inverse is, it's two numbers that add up to be 0. Okay, and so hopefully you can see that anytime we get two multiplicative inverses, their exponents are going to essentially be additive inverses. So there's this relationship between multiplicative inverses in the monomial world. Yeah, that didn't work very good. And additive inverses in the integer world. I should probably just put z. You can handle that. Okay. So that's kind of the main idea I wanted you to realize, is that there's this relationship between these two things, because to represent a multiplicative inverse in the monomial world, we basically are just using the additive inverse of the integer exponent, in this case 2 and negative 2. So if that didn't make it any more clear, come tell me so I can redo the video and have it make a little more sense, hopefully. Let me know what questions you have or whatever. Where this is going, though, kind of the spin-off of this, it's going to be the next section, is we talked about, exponents that are whole numbers, and now we've just introduced you to exponents where this guy may be a negative whole number. Okay. Well, the next step is what happens if we allow that exponent to be some rational number, like, for example, x to the 1/2. Okay. How does that change things? So tune into the next video, and we'll explore this.